Hey there YouTube. Today I'm going to talk about diagnosing furnace problems. Like a lot of you, I like to watch YouTube videos to teach myself how to do things. Like if my car's not running right, I might pop the hood and try to figure out what's wrong. Well, same thing goes on with furnaces. It's pretty common I go to a furnace call for no heat and there's a chair sitting in front of the furnace and boxes of parts are in front of it that the homeowner maybe tried to fix it themselves. They stared at their furnace and thought it was this part or thought it was that part. It's sometimes better to call a professional that can actually diagnose the issue and do some testing. One of our tool manufacturers has a saying that if you're not testing, you're guessing. This is the inside of an 80% efficient furnace. And it's got a low voltage, that's these wires right here, a low voltage series safety circuit, which has a whole bunch of special switches and sensors that are there to make sure that your furnace is operating properly. For instance, there's a switch way in the back here called a high limit. If your furnace were to overheat, that would make your furnace not work. Here's another temperature sensor. The video I'm posting today talks about this piece right here, which is a pressure switch. That's designed to make sure that your furnace is venting properly. And sometimes there's codes that would blink down here. There's a little series of codes that are listed up right there that might say pressure switch not closing. So people are tempted to just change out that pressure switch. Without the correct instruments to test what's going on, you might incorrectly fix your furnace in a way that makes it unsafe to operate. That's what I'm talking about today. That pressure switch is part of the safety circuit of your furnace. It's designed to make sure that your furnace can properly vent all the products of combustion safely out of your house. Something as simple as a blocked flue or as serious as a bad heat exchanger can make that pressure switch not close. To make sure I had the proper diagnosis, I used a manometer today to verify what was going on in that furnace. This is a tool that most homeowners don't have, but professional HVAC contractors would have in their van to make sure they have the correct diagnosis. Over the years, I've had some pretty interesting causes for a pressure switch not closing. I'll show a few of them to you on some pictures before I get to today's issue. A plugged secondary heat exchanger can keep your pressure switch from closing. Maybe ice on your intake or exhaust pipes. A broken or disconnected flue pipe can keep that switch from closing. Maybe a bird blocked your flue pipe. Maybe somebody put 5 tennis balls in your intake. So I'm working on 125,000 BTU of Amana. When I first got here, the pressure switch wasn't making. So I thought, oh, well, the pressure switch is bad. But I ended up taking out my pressure tester, which I'll grab here, and I found out that the inducer motor, which is normally right here, wasn't making enough draft. So this is the tool that I use when I have a pressure switch issue. It's a dual port manometer and pressure switch tester. I want to make sure that the switch is operating like it should, or if the switch is broken. So what I have here is this machine has a little pump built in, and I've got a couple hoses and 2 electrical leads, and I'm hooked up to the pressure switch. What I'm going to do is I'm going to start watching this little light here that says closed. I'm going to increase the pressure, or the vacuum that I'm drawing across that switch, to see when that closes. Now I'd verify where it's supposed to close, and I'm slowly increasing, and I know I'm getting close to where it's supposed to be. So just about there, and right there at 0.88 is actually where it closed. That pressure switch closed. So if that's where it's supposed to close, that means the switch is operating like it's supposed to, and I need to look somewhere else in the furnace. It's not a pressure switch issue. It might be something else. So I tested the pressure switch with my dual port manometer here, and it was making and breaking like it's supposed to. It's rated at 0.55 inches of water column fall. So I actually checked the inducer motor, and it was not pulling 0.55. So first thing I did was check the heat exchanger. It looked okay. Now I'm going to look at replacing this inducer motor, and I already got the part, so we'll throw it in and then we'll check the new inducer. Alright, I've got the new inducer in. I just put a couple of screws in to hold it in place real quick. The old motor is only pulling 0.50 or 0.45. Let's see what this one does when I flip it on here. Let's see if I can get that out of the way. Look at that, 1.27. 2.5 times what the old inducer was. So this is a good example of don't get tricked into just thinking you've got a bad pressure switch. Actually get out your test instruments and verify that your inducer motor is doing what it's supposed to do. So the moral of today's video is As tempting as it is to read a fault code on a furnace or maybe on a car and try to fix it yourself, sometimes guessing at what parts you need can lead you down a dangerous path. Sometimes it's better just to call a professional. Thanks for watching.
Thank you for calling Hyde Heating and Air Conditioning.